third quadrant, fourth quadrant. In the first quadrant, it will be 0 to pi by 2, and then second quadrant pi by 2 to pi, and then next 3 pi by 2, and then it will come to 2 pi. You can see sine x plus 2 pi. Sine x plus 2 pi will come in the first quadrant. So sine is positive, therefore we get this as sine x plus 2 pi is equal to sine x. Similarly, we have here student for cos. Again, it will come in the first quadrant, therefore cos is positive. So all are positive. So I have taken here A. A means all are positive in the first quadrant. Please remember this. Further, we also have a property stating that a linear combination of periodic function having period t is also periodic of period t. Please remember this. And after that, we see Fourier series f of x be a periodic function with period 2c defined in the interval alpha comma alpha plus 2c. So this is very important definition. So what we say is, if you take a function f of x be a periodic function with period 2c defined in the interval alpha plus 2c, f of x is equal to a naught upon 2 plus summation n 1 to infinity a n cos n pi x upon c plus summation n 1 to infinity bn sin n pi x upon c is known as Fourier series. Please repeat this formula, practice this formula, because throughout this full unit or chapter, this formula is very important. Also, we come across where, yes, also we come across where this a naught, an and bn are defined like this. That is, they are also known as Fourier series given by Euler's formula. That is, a naught is equal to 1 upon c integration alpha to alpha plus 2c f of x dx, and next we have a n is equal to 1 upon c integration alpha plus 2c f of x cos n pi x upon c dx. Similarly, we have bn is equal to 1 upon c integration alpha to alpha plus 2c f of x sin n pi x upon c dx. So I think you have come across what is this alpha to alpha, that will be your interval alpha to alpha plus 2c. These are the interval. So please remember, these are the interval students. And a naught, a n, b n are known as coefficient of Fourier series and are given by Euler's formula. So please remember this. So we'll just go through some of the important formulas here students. So please remember, throughout this Fourier series you must practice this formulas. That is, cos n pi is equal to minus 1 raised to n. Next, sin n pi is equal to 0. Cos n 2n plus 1 pi by 2 is equal to always 0. Sin 2n plus 1 pi by 2 is equal to minus 1 raised to n. Then remember again formula, that is integration e raised to ax cos bx dx is equal to e raised to x divided by a square plus b square a cos bx plus b sin bx. Similarly, integration e raised to x sin bx dx is equal to e raised to x divided by a square plus b square a sin bx minus b cos bx. So please remember this formula students. Again, we are going to use a very simple formula, that is Bernoulli's rule. So it says that integration u into v dx. Many applications are there in this product of integration. So integration u into v dx is equal to, keep u as it is, v1 integration one time minus u dash is differentiation one time, v2 is 2 times integration, u double dash is 2 times differentiation, v3 is 3 times integration, and so on. So I have written here v1, v2, v3, u dash, u double dash. We'll just go through what is this Fourier series and Fourier's analysis. Here you can see in the summary, Fourier analysis for periodic function focus on the study of Fourier series. So very simple they have given here, and it's a periodic function. Yes, you can see the period, how it will be, time taken. Yes, time is very important students. So it focus on study of Fourier series. Definitely in your exam, time is important. Very short period will be given. Use that function, that is time, and simplify very easily and quickly. Next, we'll go through the Fourier transformation. Is always the transforming a continuous signal into frequency domain. So please remember this. Discrete time Fourier transformation is a Fourier transformation of sample signals. The discrete Fourier transformation, discrete numerical equivalent using sums instead of integral, that can be computed on a digital computer. I think this means what? You have a lot of numerical equivalence. You are going to add, you are going to divide. Yes, means you are going to use many integrations and many differentiations in this. It is a combo of integration and differentiation. There's a Fourier series and Fourier transformation. So as one of the application, that is DFT, discrete Fourier transformation, and then inverse discrete Fourier transformation can be used to compute standard convolution product and thus to perform linear filtering, students. So means any product is given, anything, any value is given, Fourier series is very helpful to simplify. So I've just list out these, students, very important applications of Fourier series. That is signal processing. Yes, very important, very large application. This is a signal processing. So now you can see everywhere there is a signals. Signal is not there, your mobile is not going to work. You don't get the internet. You are not going to connect to the class because of the internet. You cannot upload properly. Yes, if you want to upload any file, any answer script you want to upload, if you have the weak signals, you cannot upload. It will be delayed. Same we have image processing. Image processing, what we have done, you send the image. Yes, you are using WhatsApp and everything. You are sending the images, right? To this process, we use Fourier series. And very next important, that is heat distribution mapping. Yes, you can see. Yes, ACs are there, heaters are there, coolers are there. Everywhere this is mapped. It is distributed properly and it is mapped. So it is heat distribution mapping is done by using Fourier series. Similarly, we have wave simplification. Okay, light simplification we have. You can see the interference and diffraction. Yes, in the light simplification. Similarly, we have radiation measurements. Students, very important. Radiations. You see, mobile has radiation. So altogether, it is going to control, as well as it has been Fourier series. It has been used in this application. Now let's just see, go through the Fourier analysis. So in this Fourier analysis, we come across actually the Fourier series. Means you are going to analyze how the functions are going to act and how they differ and what are its uses, application, significance. We are going to analyze here using the example, students. So first we'll go to the Fourier series. A Fourier series is a representation of functions using a series of sinusoidal functions of different frequencies. Means there are various different frequencies, that will be long frequency, short frequency. Yes, you can see, you can send the files. Now you can use the Bluetooth. Now it has been modified as, now you can see the share it is there. Yes, so many are going to share the things. How you will have the frequencies, so it depends on these functions, which type of function they are, sinusoidal functions, where is we are going to see in the Fourier series. And if you just recall, students, Taylor's and other power series expansion, you can see more applications we can see in Fourier series. We have a lot of applications for Taylor series and other power series function in calculus, but here in numerical methods, Fourier will give you a lot of information and it will define the series and you can get the beautiful answers. They are extremely useful to use to represent functions of phenomena that are periodic in nature. So it is going to relate everything. Yes, everyone is studying for the exam. You are going to pass the exam. You are going to get the rank. Yes, everyone is going to study. But how it has been calculated? There must be some medium, or we are going to give the some analysis, that is exam. Same way, Fourier series will give you all the values and calculate and give you beautiful phenomena that are periodic in nature. And similarly, in the Fourier integral, and transformation, similar to Fourier series, but extended its application to both periodic and non-periodic functions and phenomena. Students, Fourier series will be periodic functions, but in Fourier integral and transformation, you can see a large application with periodic. There are also non-periodic functions and phenomena. The first developed by the French mathematician, yes, he's a French mathematician, Joseph Fourier, in 1768 and 1830. Okay, so this is a little bit about the Fourier analysis and Fourier series, Fourier transformation we have come across. Okay, students. Now we are going to see the next one, that is how we are going to use the examples. Now just see, we go through the odd and even functions. Yes. So here we see odd and even functions. So function f of x is said to be even if f of minus x is equal to plus x. Means how this will be plus and minus. If we take a minus 1 square, which is equal to nothing but minus 1 into minus 1, it will be positive. Means this function is there, which we are going to say this is an even function. When we square it, we are going to get plus 1. So similarly, we are going to take a function that is in negative sign. If you substitute cos minus x, will give you plus cos x. You can see this is a even function. Similarly, we have sec x, x square. These are the examples for even functions. We'll go to the functions. F of x is said to be odd if f of minus x is equal to minus f of x. So you can take the example, beautiful example, that is sin x. You can see sin minus x will give you minus sin x. So you can see here, yes, sin x will give you minus sin x. Suppose if you take minus x cube, will give you minus x cube. Means minus, if you substitute 1, minus 1 cube will be giving you minus 1, which we'll call it as odd function. Symmetric, so we go next one, that is symmetric about y-axis and symmetric about origin figures. You can see even is always symmetric about y-axis. So you can see this curve is exactly symmetric mirror image of LHS is equal to RHS. This curve is LHS is equal to RHS, is a mirror image. And next, odd function, for odd function, symmetric about the original figure. So you can see this line, this curve is exactly equal and symmetric about the origin. So please remember this. Next, we'll go to see the for even functions, Fourier expansions combines only 4 cosine terms. So very important, you can see here, even functions are cosine functions, odd functions are sine functions or sine terms. Please remember this. Suppose they have given the interval minus c to c. So a naught will change now. A naught will be equal to 2 upon c integration 0 to 2 f of x dx. An is equal to 2 upon c integration 0 to c f of x cos n pi x upon c dx. And bn is always 0. Please remember this, students. The even functions are cosine functions, and we have defined a naught, an, bn. Please remember this formula. Similarly, go to the odd functions, Fourier expansion combine only to sine terms. Please remember this. Odd functions, Fourier expansions combined only to the sine terms minus c to c. You can see what are the expansion. An naught is equal to 0, an is equal to 0, bn is equal to 2 upon c integration 0 to c f of x sine n pi x upon c dx. So please remember this, even and odd functions. Yes. Now we'll just see. Fourier series is a powerful method to solve ordinary differential and partial differential equations with periodic functions appearing as non-homogeneous terms. Yes. For non-homogeneous also, we are going to use this very powerful series, friends. Now, in general, we are going to define this. Let f of x be a periodic function with period 2l defined in the interval c plus 2l be the sum of trigonometric series is. So this is very very important. F of x is equal to a naught upon 2 plus summation n 1 to infinity a n cos n pi x upon L. So L is nothing but the length plus summation n 1 to infinity b n sin n pi x upon L dx. Please keep this equation 1 where a naught is equal to 1 upon L integration c to c plus 2 L f of x dx. A n is equal to 1 upon L integration c to c plus 2 L f of x cos n pi x upon L dx. Right? So please remember this. Similarly, Bn is equal to 1 upon L integration c to c plus 2L f of x sin n pi x upon L dx. So please remember this. A naught, An and Bn. Throughout these examples, we are going to use this formula. We are going to use A naught, An, Bn according to the interval. Suppose the interval may be from pi to minus pi, interval changes. Even from 0 to 2 pi, 0 to pi is there. So all this interval will change accordingly. Please remember equation 2, 3 and 4 are known as Euler's formula because Euler has given this formula. Yes, I think you have come across Euler. He was a scientist, very mathematician. He is. Yes, Euler's formula has given this A naught, An and Bn. So please remember, very very important, friends. Yes. So now we'll go with quickly examples and we try to simplify this example, friends. So we are very well with, we have understood what is Fourier series. We have gone through the periodic functions, right? Then we have seen the summary of the Fourier series. We have come across Fourier scientist, and then we have seen the applications. Okay, students. Now we will go through the example which are important for your examination purpose, and I have made it very easy. So you can see, we'll go with the example 1. Okay, so we'll take the example 1 student. Now you can see, obtain the Fourier series for the function. So here they have told you Fourier series of the function, that is function we are going to take x square. So this is very very important in the question, and they have given the interval as we have discussed about how the interval will affect the Fourier series, and hence they have also given that we have to deduce this whatever Fourier series we get, we are going to deduce for 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square and so on. Yes, here they have taken minus 1 upon 4 square. So it is alternative. It will go till pi square upon 12. So you can see this is a series, friend. Next, they have taken this as 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square and so on. This series will go to pi square upon 6, students. Is it clear? So this is a very simple question they have given. I'll immediately go for the solution. So first, whenever the Fourier series is given, you have to remember the formula. I have told you to remember the formula. The formula here is, yes, it is f of x is equal to a naught upon 2 plus summation n 1 to infinity a n cos nx plus summation n 1 to infinity, it is bn sin nx. So we'll keep this equation 1, students. So when you write the formula, very simple, substitute a naught, an, bn. So please remember, when substitute a naught, an, bn, please remember the formula for a naught is equal to 1 upon pi integration minus pi to pi f of x dx. So substitute these values. First we'll simplify this value taking the function. So you can see here they have given the function. I'm going to take this f of x is equal to x square in the interval minus pi to pi. So I have directly taken minus pi to pi. So you can see here, you can see c is equal to pi. Is it clear, students? Okay, now I'll just simplify this now. Yes, first we'll simplify a naught, students. So substitute the values 1 upon pi, c is pi, therefore I substitute pi. Integration is from pi to pi, they have given directly the interval. Okay, now you can see f of x, just substitute x square and this remains as it is, that is dx. Now you can see this is equal to 1 upon pi. So integration of x square is x cube upon 3, student. So please remember, integration formula for integration x square dx will be equal to x cube upon 3. Please remember the formula from the interval pi to minus pi. So this is equal to, now I'm going to take 3 constant outside. So this is 1 upon 3 pi. So here remains only x cube. Now first I will substitute pi value, pi cube minus, yes, I think you have come across, that is integration f of x. This is from a to b. This will be equal to f of b minus f of a. This integration you have come across. I am substituting first b. So b I have taken here pi and a I am going to take minus pi. So therefore this is pi cube. Okay, now just simplify this, friends. So here you are going to get this is equal to 1 upon 3 pi as it is. Now I can see this is pi cube. Okay, and this will become minus into minus plus. So this is pi cube plus pi cube. Odd function, student, please remember. Yes, now I can simplify. This is going to become 2 pi cube upon 3 pi. 1 pi will get cancelled. Therefore, I am going to take this as 2 pi square upon 3. So this is how you have to simplify one by one a naught, an, bn. So if you simplify, finish, student, half of the 80% of the problem is solved. Just substitute a naught, an and bn in the formulas. It's a very simple, students. So now we'll go to the next one. I will try for an. So please remember the formula, friend. An is equal to, I will take this as an is equal to, so now I can see an, I'm going to take this as 1 upon pi integration minus pi to pi, yes, f of x, and this is cos nx dx. Substitute the values, students, one by one. I'm going to take this as, because c is again pi, so I have taken 1 upon pi integration minus pi to pi f of x cos nx dx. Please practice this formula, friends. And depending on the interval and the given function, you have to substitute here. So okay, so I'm going to substitute now. That is f of x, I'm going to substitute here as x square. So I'm going to take this as integration minus pi to pi x square cos nx dx. So you can see here also it is n pi x upon c. C is nothing but again your pi. So pi will get cancelled, cos nx. So I am not simplified, it is understood. N pi x upon pi will be nx. So please remember this. I'll just write here n pi x upon pi. I'm going to get this as nx. So pi will get cancelled. Okay, no problem. Now I can see I'm going to use the very important tool, that is Bernoulli's rule, u into v. Integration of two functions. So x is a function and cos is a function. X is a algebraic function, arithmetic function, and you can take this as cos x as the trigonometric function. So please remember the formula from Bernoulli's rule, students. It is integration of product of two functions, which is equal to, sorry, keep u as it is, then integration v1 you are going to do. Similarly, you are going to take plus u dash. I think one time differentiation you have seen the formula, and this is v2. Yes, please remember this is plus, then you are going to get here minus. V2 is nothing but 2 times integration, continue this, plus u double dash v3 minus u triple dash, and this is v4, and so on. So very very important tool this is, we are going to use in this function. Now you can see one by one I am going to simplify this. Please understand 1 upon pi. Already you have come across integration, right? So first I'm going to use this formula now. I'll just substitute the value, students. Yes, fine. So I'm going to take, first I will keep x square as it is. Okay, I can see integration of cos, so I'll write here one by one. So u I have taken this as x square, and v I have taken this as cos nx. So when I go for u dash, differentiation of x square is 2x. Again, if you just differentiate 2 times, it is going to become 2, and u3 is going to become 0. Similarly, if you integrate this one time, you come across cos nx. Integration of cos nx is what, students? Yes? Okay. So this is sin nx constant, that is n will be there. Again, if you just integrate this once again, integrate this sin nx once again, n is constant, so I'll write 1 upon n outside. Sin nx integration will be, yes, it is minus cos nx upon n. If you further simplify, you are going to get this as minus cos nx upon n square. Okay, now go for third integration, is not there. You can see it is u3 is 0, means no need to calculate, not required. Why it is not required? Because u triple dash, that is 3 times differentiation is 0, so not take till there. So x square will substitute. Now v1, yes, use this formula, friends. So u I have substituted, I am going to substitute v1. V1 is nothing but sin nx upon n. Okay, next it is minus, so I'll substitute here minus. Okay, u dash is 2x. You can see inside I have done rough work, and then substitute v2. V2 is what, students? Yes, it is minus cos nx upon n square. And next, if you further simplify, it is 0, because u triple dash is v2. V1 I have substituted. Okay, no problem. Yes, plus now u double dash, you are going to get this as 2. Fine. And then you can see differentiation again. Once again, if you differentiate, you are going to get this as minus sin nx upon n cube. So it is from minus pi to pi. So here you can see I have not taken v3. So till v3 it is going to go definitely. So I'll just show you how v3 you can simplify this. So yes, I will show you v3. So this is already you have calculated v2, that is minus cos nx upon n square. Once again you integrate, keep minus outside. This is 1 upon n square remains cos nx. Now how you will simplify cos nx? Yes, cos nx is nothing but, students, sin nx upon n. So I will just take sin nx upon n. If you further simplify, v3 is equal to, it is minus sin nx, n will multiply, it is n cube. So I have substituted here So you can see this is u v1, and this is u dash v2, this is u double dash, and this is v3, students. So you can see u triple dash will be 0, means no need of calculating v4. Okay, please remember this. Now, okay, further simplify this, students. So we can see I will keep this equal to 1 upon pi. You can keep it as it is. Yes. Now you can see, remember the very important formula, please. That is sine n pi will be always equal to 0. Is it clear? And you can see here we have sine. This will become 0, and this equation will become 0. So what is remaining? Yes, this only this value is remaining. So I'll just take minus into minus will become plus. So what is remaining here, student? It is 2x cos nx upon this n square. So it is from minus pi to pi. Further, if you simplify this, students, you can see, yes. So what I will do here, what are constant terms? 2 and n square is constant, so I will remove it outside. 2 pi n square I will remove. Okay. So again, I am going to substitute here upper limit pi, lower limit minus pi. So x will become here pi, and this is cos n pi minus, here we have again x minus pi, cos n minus pi. So I think you have come across that is cos, yes, cos minus pi will be equal to, it is plus cos pi, because this is a even function. Please remember this. This is by definition of even function. This is plus cos pi front. Now in the substitute here, this is equal to 2 pi n square remain here, students. This is pi cos n pi, minus into minus plus, pi cos n pi will become 2 pi cos n pi, students. So already I have given the formula list. Yes, in the formula it is clearly mentioned, that is cos n pi will be equal to minus 1 raised to n. So just substitute this value, students. I can see we are going to get an. An is equal to 2 into 2 will become 4, and this pi value will get cancelled with this pi. Okay, cos n pi is going to become minus 1 raised to n upon n square. So this is our an. So we are going to substitute an, students. Okay, so this is how we are going to substitute one by one. We have calculated a naught and we have calculated an, students. Similarly, we are now going to calculate bn. Just substitute and simplify this bn. We are going to get the answer. So first I am going to put the formula. Please remember the formula. Here c is equal to pi we have taken, and therefore 1 upon pi will become this formula. Integration interval they have already given, that is from minus pi to pi. And remember this function f of x, it is sine x dx, sine nx dx. Please remember this formula, students, and substitute the values now one by one. So sine nx dx. Okay, now substitute the values, students. I think you remember f of x we have taken here x square. So substitute here x square sine nx dx. Again you can see this is actually n pi x, but c is pi, therefore we get this as sine nx. Okay, pi will get cancelled, therefore I have directly written sine nx. Please remember, once again I will repeat. So here sine n pi x divided by the c. C we have taken the interval pi. Therefore sine n pi x upon pi will be going to become sine nx. So please remember this. Now you can see here, student, again the same formula we are going to use. I will show you once again, that is product of two functions integration we are going to find, that is keep u as it is, integrate v, this is plus minus u dash v2 plus u double dash v3 minus u triple dash v4 and so on. So this is Bernoulli's rule. So first we'll take u. I will take u as x square and v is equal to sine nx. Okay, one by one we'll simplify. Okay, substitute the values. U dash, u dash you are going to get this as 2x. Then u double dash you are going to get this as 2, and u triple dash will become 0. Similarly, we'll go for v1. So integration of sine x you are going to get this as, it is minus cos cos nx upon n. If we further simplify, integrate this, so minus 1 upon 1 I'm going to take outside. So I'm going to take minus 1 upon n outside. Integration of cos nx. Yes, student. Integration of cos nx is nothing but sine nx upon n. Further, if we simplify, we are going to get this as minus sine nx upon n into n. If you multiply, you are going to get this as n square. Okay, so if you further continue like this, you are going to get v3 is equal to, I will take again common, I will remove minus 1 upon n square, that is the constant terms I am going to remove. So further, if you get integration of sin x, integration of sin x is, I think you have done already, that is cos minus cos nx upon n, students. So you can see minus minus will get plus, and n square into n we are going to get n cube. Therefore the value we are going to get cos nx upon n cube. So this is our v3. So please remember, and no need of finding v4 and so on. So now we'll substitute one by one using the formula Bernoulli's rule. So you can see I'm going to take here the values. I'm going to substitute 1 upon pi, I will write as it is. Integration of u into v is this. So I'll substitute first u x square. v1 will be minus cos nx upon n. Next, minus u dash is 2x. Then we have v2. v2 is minus sine nx upon n square. Okay, plus it is u double dash 2, and v3 we have cos nx upon n cube. So all this value we have substituted in this formula, that is integration u into v. Again this will be minus pi to pi. So please remember this. Already I have told you to remember very important formula, that is what is sine n pi. It's always 0. So please remember this formula. If this is 0, students, automatically this will become 0. No need of calculating it once again. So whatever the constant terms are there, I will remove it outside. So you can see here this is equal to, and substitute the values here. 1 upon pi I'm going to take outside. What is remaining here? Yes. So I'll just substitute one by one. So here you can see x square and pi is there. So you can, if you take this value, I'll substitute first pi value. So I'm going to get this as pi square upon n. I will keep it outside. We have here minus cos n pi. Okay, so I first substituted pi value, then go for substituting minus pi. So this will be continued like this, minus pi square, square upon n. So I'm substituting minus pi, students. So minus cos n minus pi. Okay, so first this value was simplified pi value. Then now I'm going to go to simplify minus pi. So minus pi square upon n. This is again minus cos n minus pi. Pi, then minus pi simplified. Now I'm going to substitute here pi value. So pi square upon n minus cos n plus pi. I have simplified here. For this value, I'm going to substitute pi and minus pi. So now I can see, yes, very good. You are right. So therefore, this is plus 2 into cos n pi upon n cube. I'm going to substitute this value. Yes, you can substitute this values in this form, or instead of simplifying like this, you can also substitute first pi and then minus pi. Okay, so now I'm going to substitute here minus pi. Okay, sorry. So this is again minus. So I'm going to get here 2 cos n minus pi divided by n cube front. So don't get confused. Once again, I will repeat this. You can simplify solving like this, or you can directly simplify like this 1 upon pi. First, you substitute pi value in the equation. So the equation you are going to get here is, yes, it is pi. I will substitute first. That is pi square minus cos n pi upon n. Okay, this is plus 2 cos n pi upon n cube. So pi value is substituted. Now you are going to substitute minus pi. So this is minus pi square minus cos n minus pi upon n. Next, this is plus 2 cos n minus pi upon n cube. Both ways you can simplify. Yes, please remember here minus is outside. This is what we have, f of b minus f of a. That is the integration we are going to get. That is integration of f of x dx is equal to. Okay, I can just simplify this, friends. You can see this is equal to 1 upon pi. I can take here. Okay, I can see minus I am going to take outside. Minus pi square upon n cos n pi. Here you can say, yes, it is only plus 2 upon n cube. This is going to become cos n pi. Here we have minus, and minus pi square will become plus pi square. Plus pi square. Here we have again minus. Minus into minus will be plus. So cos n minus pi is again cos n pi. It is a positive value. It's a even function. Then next minus is multiplied here. Minus 2 upon n cube. Cos n minus pi is again the even function. Therefore, it is going to get plus. Now you can see the here, students. This is minus and this is plus. So both will get cancelled. Similarly, these two values will get cancelled. Means altogether it is 0. Therefore, you get the Pn is equal to 0. So you have calculated A naught. So I will just rewrite once again. A naught is equal to 2 pi square upon 3. So just write once again 2 pi square upon 3, and An you have calculated here, that is 4 minus 1 raised to n upon n square. So you can see you already calculated here 4 minus 1 raised to n upon n square. So like this you have to calculate A naught, An and Bn, and then substitute in the Fourier series formula, that is f of x is equal to A naught upon 2 plus summation n1 to infinity an cos nx So substitute here, students. So therefore, I'm going to get this as f of x is equal to it is a naught. A naught, if you just see, it is 1 upon 2 into a naught. I'm going to take, that is a naught upon 2. So here it is 2 pi square upon 3 plus, yes, it is summation n 1 to infinity. An is 4 minus 1 raised to n upon n square. Okay, so this values we are going to get, students. Is it clear? Fine. And this is cos nx plus, this is 0. Please remember bn is equal to 0, therefore this value will become 0. So now I can simplify further. This is function, you are going to get f of x from Fourier series. 2 will get cancelled. So it is pi square upon 3 plus summation n 1 to infinity 4 minus 1 raised to n upon n square cos nx. So this is the function, student. So please remember this, very important. We have calculated from Fourier series. Now we have to deduce this equation, students. So I can see here, without wasting the time, you can see we have to calculate 1 and 2. So first I think I'm going to take the value 0. Let us try. We'll put x is equal to 0. That implies f of 0. Yes, this is the first part I'm going to prove. F of 0 is equal to, wherever x is there, please put 0. So this is plus summation n 1 to infinity 4 minus 1 raised to n upon n square. Here you can see cos 0. So cos 0 is 1. So I'm going to substitute here into 1. Okay, further if we simplify, also please remember f of x is equal to, we have taken the function x square, f of 0 will become 0. So this is 0 is equal to pi square upon 3 plus, I can see n, I'm going to substitute n is equal to 1. So 4 I will take outside. Okay, 1 by 1 I will substitute, minus 1 raised to 1. Okay, this is 1 square. Then plus, now I'm going to substitute n is equal to 2 minus 1 raised to 2 upon 2 square plus minus 1 raised to 3 upon 3 square, and this function will continue because it's a Fourier series. You are going to, the function will be continued. Okay, so what I will do here again, I will take, yes, pi square upon 3 on this side is going to get minus pi square upon 3, which is equal to 4. Is it clear? So further if you simplify, you are going to get this as minus 1 upon 1 square. 1 square will become plus. So 1 upon 2 square. Here minus 1 cube will become minus 1 upon 3 square, and so on, students. Okay, further if you simplify, I will take this 4 on this side. It is going to get, I will get this as minus pi square upon 12 is equal to this value as it is. Keep this value as it is, students. Don't change this value. Okay, I will multiply minus on the both the sides. Multiply minus 1 on both sides, students. So please again minus this here. So I'm going to get this as plus, and if you multiply here minus, here I'm going to get 1 square minus, wherever plus is there, minus will become, and wherever minus is there, we are going to get this as plus. I can see pi square upon 12 is equal to 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 4 1. So we have calculated for first value. So we have proved first one. Now we'll go to the second one. To simplify second one, student, yes, please remember I'm going to substitute the value. So similarly, I'm going to substitute for the second value. Put x is equal to pi. So let us see, when I substitute x is equal to pi, what I'm going to get in the equation. Here I'm going to take the equation as a. I'm going to substitute this equation in a. I'll put it in equation a. So x is equal to, I'm going to take this as pi. Okay. So f of pi is equal to, now you can see, substitute the value. So pi square upon 3 remains as it is, plus summation n 1 to infinity will remain as it is. 4 minus 1 raised to n upon n square will remain. And here you can see it is cos n x. X is pi. So I'm going to substitute pi. And you should remember that cos n pi, already we have substituted the value it as minus 1 raised to n students. So when you substitute minus 1 raised to n, and if you further simplify this like this, I can see minus 1 raised to n, here we have minus 1 raised to n, and if you take another minus 1 raised to n, so you can see there are 2 n are there, therefore minus 1 raised to 2n. So this is an even function. Even function minus sign will be always positive only. So directly I'm going to take this as plus 1. So means this full function, this and this value will be equal to 1. So what will be the value remaining? Here you can see f of x is equal to x square. If you take this as pi value, you are going to get this as pi square student. So you can just substitute here. So I'll directly substitute here. Pi square is equal to pi square upon 3 plus, this is summation n 1 to infinity 4 upon n square. Please remember, we have already calculated here the value, that is minus 1 raised to n cos n pi will be equal to 1. Okay, because this is minus 1 raised to n and cos n pi is again minus 1 raised to n, which is equal to a positive value. We can get this as minus 1 raised to 2n, which is always equal to 1. So this is value we get here students. So I'll bring this pi square upon 3 on this side. So you can see this is pi square minus pi square. You can just simplify this students, very easy. This is equal to summation 1 n 1 to infinity. So I'm just substitute wherever n is there, I'm going to substitute this as 1 square plus 1 upon 2 square, 1 upon 3 square, and so on. Further, if you simplify this, I'm going to take 3 this side. 3 pi square minus pi square will become 2 pi square upon 3. Please remember, this is 2 pi square upon 3, 4, and this remains as it is. So I'm going to substitute the third value, friends. Okay. Now 4, if I bring this side, this is 2 pi square upon 3 into 4. Again, you can take this as 2 1 za, 2 2 za. So you can take this as pi square upon 3 into 2. It is 6, which is equal to 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square remain as it is. Therefore, we have proved that pi square upon 6 is equal to 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square, and so on. So second also we have calculated and proved that pi square upon 6, you can see here they have told you to calculate 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square plus so on. We get this as equal to pi square upon 6 students. So like this you should able to calculate. So please calculate the next example, very simple students. Yes, try the next example, which is given as, yes, obtain, again same, obtain Fourier series. So second example, you can try the second example, obtain the Fourier series. Try yourself, students, for the function. So here, please remember only the function is going to change. The function they have given here, f of x is equal to e raised to minus x in the interval minus pi to pi. Yes, minus pi to pi. You have to calculate this value, students. Okay, you can try yourself. Yes, if possible. Those who are getting still confused, for them, I will simplify. Obtain the Fourier series for the function f of x is equal to. So first you have to remember, first write the formula, that is, again once again I will repeat the formula. F of x is equal to a naught upon 2 plus summation n 1 to infinity an cos nx plus summation n 1 to infinity bn sin nx. We'll keep this equation 1. So again you can see c is nothing but pi. Therefore you can see here n pi x upon c will be n pi x upon pi. So I have taken this as nx. Directly I have written cos nx sin nx. Okay. Yes, students, please try yourself. So I think we'll start from a naught. Substitute a naught, an and bn in this formula. Let's see your work. So one by one I will start. That is a naught is equal to, yes, please remember here c is nothing but we have taken c is here pi. So please remember 1 upon pi I am going to take. Again the interval they have already given, students, from minus pi to pi, and this is your f of x dx. Okay, so simplify, students. Substitute what is f of x. Okay, so this is equal to 1 upon pi integration minus pi to pi e raised to minus x dx. Fine. So integration of, first you see what is integration of e raised to x. Integration of e raised to x is e raised to x, but integration of, you remember this formula, students, that is integration of e raised to ax is equal to e raised to ax upon a. Please remember this. Now here you can see a is nothing but minus 1. E raised to minus x it is. So therefore 1 upon pi is a constant I have written as it is. E raised to minus x will become e raised to minus x upon minus 1. Integration from minus pi to pi. So you can just substitute here the value, students, that is, this is equal to 1 upon pi. So first I will substitute pi, upper limit e raised to minus pi I will get. Yes, minus I will take outside. Minus 1 I have taken outside, student. Please remember. So this is again minus e raised to minus of minus pi. So further if you simplify, I am going to get this as minus 1 upon pi e raised to minus pi minus e raised to minus into minus, it is plus. Therefore, we have calculated this value. Also, if you remember the value, I will just interchange this. I will take out minus outside from this equation. In the bracket I have taken minus, minus and minus will become plus 1 upon pi. Just for simplification, e raised to pi minus e raised to minus pi. Okay, for simplification I have just taken from this bracket minus outside. So you have to, one formula you have to directly remember the formula, that is e raised to pi minus e raised to minus pi. I think you have come across, this is equal to 2 sin h pi. This formula, please remember. Okay, remember this formula. This is a new formula, so please write it down. So now we are going to substitute this value in the equation. Therefore, I am going to get this as a naught is equal to, just for simplification, this is 2 sin h pi upon pi. Only for the simplification, students. I have taken this value. Okay. Now we will go to the simplifying an. So please remember the formula once again. Yes. What we are going to calculate here, students? An. Okay. Please try yourself, students. Now you must be perfect now. So I'm going to take an formula. What is an is equal to, students? Yes. C is pi value, therefore 1 upon pi. Integration from minus pi to pi. F of x cos n pi x upon c. So c is pi, therefore nx we are going to get here. Now substitute f of x runs, it is e raised to minus x, so 1 upon pi. Integration minus pi to pi. E raised to minus x cos nx dx. So here you are going to use that very important formula. Please remember, substitute the value correctly. You have to remember this very important formula I'm going to write here. That is, yes, it is integration e raised to ax cos nx formula. You should remember this, students. This is equal to e raised to ax upon a square plus b square. Instead of here n, we have to take here b. Okay, no problem. This is a cos bx. Okay, a cos bx plus, yes, plus b sin bx. Please use this formula. You can see in the equation they have given e raised to minus x, means a is equal to, I have to take minus 1 and b is equal to n. So please remember this and substitute one by one. Okay. So I'm going to take this is equal to, now 1 upon pi I will keep as it is. So I'll substitute for integration. Yes. So this is equal to, okay. So e raised to minus x divided by a is minus 1 square is 1 plus b is n. So this is directly, I'm going to take this as n square. In the bracket, this is again a cos bx, means minus cos nx, okay, plus b sin bx. So it is n sin nx. Integration from minus pi to pi. Please remember this, students. Okay, I can see already I have given the formula. Please remember this always. Whenever cos n pi is there, which is equal to cos n minus pi is there, this will be always minus 1 raised to n. So please remember this very important formula. And because we have another formula, that is n cos n pi. Please remember, cos n pi or sorry, sin n pi or sin n minus pi will be always equal to 0. So means this value is already 0. So I'm going to substitute only pi value in this, pi and minus pi in this. So minus is minus cos nx we have, minus I will keep it outside, therefore this is equal to, I'll remove this outside. So 1 upon pi I will keep here and minus I will remove outside, and 1 plus n square is constant from, therefore I am going to take this as n square plus 1 outside. So only remains e raised to minus x. So here e raised to minus x cos nx is remaining. This is from minus pi to pi. Substitute the values, friends. So here it is minus 1 upon pi n square plus 1. First I will substitute pi value, that is e raised to minus pi. This is cos n pi minus e raised to minus of minus pi, and this is again cos n minus pi. So I've substituted the values. Okay, this is equal to, friends, what you are going to get, this is equal to, this is minus 1 upon pi n square plus 1. So you can see cos n pi, I think you have seen minus 1 raised to n. So cos n pi is both where it is constant, so I'll remove it outside, which is going to become cos n pi. So here you can see it is e raised to minus pi, and this is minus e raised to minus into minus will become plus. So please remember the two formulas. Cos n pi is equal to minus 1 raised to n, as well as e raised to pi minus e raised to minus pi will be 2 sine h pi. So please remember these two formulas, very very important students. E raised to pi minus e raised to minus e raised to pi minus e raised to minus pi is equal to 2 sine h pi. So now you can see here they have interchanged. Yes. So what I will do, this is plus and this is minus. So I will take minus outside. Already 1 minus is outside, so minus 1 into minus 1 is there. Okay, minus I have taken from outside from this bracket. Cos n pi will give you minus 1 raised to n. Okay, divided by this is pi n square plus 1 as it is. This is into. Now you can see here e raised to, I have taken minus outside, means this is e raised to pi minus e raised to minus pi I am going to get. Now further if you simplify, this is equal to minus 1 into minus 1 plus 1. So only minus 1 raised to n is remaining. Here divided by pi, n square plus 1 is remaining. E raised to pi minus e raised to minus pi is already given. It is 2 sine h pi. So this is how you have to calculate the values, friends. You are going to get this is, yes, it is a n. You can see you have calculated a naught and an. So further you have to calculate only the value, that is bn. Please calculate bn now. Yes, here c is equal to pi is there, therefore I am going to take 1 upon pi integration from minus 1 to nx dx. So substitute the values here, students. Okay, this is equal to 1 upon pi integration minus pi to pi. I think e raised to x, you know, it is e raised, f of x is nothing but e raised to minus x. This is sine nx dx. Now please remember the formula, students. Very very important formula it is. Yes, integration e raised to ax sine nx dx. Already have given the formula, that is e raised to ax upon a square plus b square, and here we have a sine nx minus b cos nx. So please use this formula now, substitute the value. Here you are going to see it is a is equal to minus 1 and b we have taken this, sorry, this is b. Okay, so I have taken here b directly. This is b. B we have to take n, so directly I have substituted at n value. Actually it is b value. Okay, so now substitute here. A is equal to minus 1, b is equal to n. So now you can see the value I am going to get here. So substitute the value, friends. This is equal to 1 upon pi. Yes. So integration, that will be e raised to minus x upon 1 minus 1 square is 1 plus n square and minus sine nx minus n cos nx, integration from minus pi to pi. So you can see upper limit is pi, lower limit is minus pi. So there are two brackets. So here also you have two brackets. Fine, no problem. Okay, now further if you just go to simplify this, students, this is equal to 1 upon pi. Now wherever x is there, please substitute pi value. But here you have to remember, students, remember the formula already I have told you, that is sine n pi is always equal to 0. So this value is 0. Similarly, this is equal to sine n minus pi. So both the values 0. Pi also 0, minus pi also. If you substitute, you are going to get this as 0, students. So please remember this. Okay. Then only remains minus n cos nx. Okay, what remains, friends? Only n cos nx remains. So that I will take outside. Again, what all constants are there, I am going to take it outside. That is n square plus 1 is constant, I will take outside. Minus is there, I am going to take minus outside. N is there, I am going to take outside. This minus n outside, and 1 plus n square outside. So what is remaining here, friend? E raised to minus x cos nx, upper limit and lower limit pi and minus pi. Okay, now substitute the values, friends. Okay, this is equal to, I'll keep minus n upon pi n square plus 1 as it is. Substitute the value of pi. This is e raised to minus pi cos n pi. Then minus e raised to minus of minus pi. This is cos n minus pi. So first I have substituted pi value, then I have substituted minus pi value. Okay, further if you simplify, this is equal to minus n upon pi n square plus 1. This value you can see e raised to minus pi is there. This is cos n pi minus e raised to minus into minus will become plus, cos n minus pi will become cos n pi. So cos n pi is constant, I will take it outside. Okay, this is equal to minus n upon pi n square plus 1. Cos n pi is constant, I will take it outside. This is e raised to minus pi minus e raised to pi is remaining. Please remember another formula I already told you. Once again I will repeat the formula, that is cos n pi will be equal to always minus 1 raised to n. And also remember e raised to pi minus e raised to minus pi is already in the formula they have given, that is 2 sine h pi. So it's hyperbolic sign. Okay, please remember this. So now you can substitute the values, friends. So this is equal to, now you can see this e raised to minus pi minus e raised to, means this is plus and this is minus. So I will take minus outside from this bracket. Okay, minus 1 I will take outside and multiply here. Minus n into minus 1 will become plus n. Please remember this. And cos n pi is minus 1 raised to pi. This is pi as it is, n square plus 1 as it is. Why I have taken this, friends? Because I want to get this as e raised to pi minus e raised to minus pi. Therefore, I have taken minus outside. Now from this you can see directly you will get the value now. You can substitute the value, that is 2 sine h pi. So this value we are going to, you have calculated for Bn. So A naught you have calculated, students. An you have calculated, yes, and now you have calculated Bn. Substitute in the formula, students. So what the formula will, you will get this as, yes, it is f of x is equal to f of x is equal to a naught upon 2, means 2 sine h pi upon pi. Okay, substitute the value. So I will take constant outside. So I will just write 1 upon 2 outside. A naught I am going to substitute here. What is the value? 2 sine h pi upon pi. It is 2 sine h pi upon pi, you will get plus. Next, this is summation n 1 to infinity. Okay, then you have to substitute an cos nx. An you have already calculated, minus 1 raised to n. Okay, so just substitute the value, students. So you are going to get this as 2 minus 1 raised to n upon pi n square plus 1 sin h pi cos sin h pi. Yes, then we are going to substitute this value in the formula. Sorry, cos nx. Okay, cos nx plus summation n 1 to infinity, and this is we are going to substitute bn formula. So that is 2 n minus 1 raised to n upon pi n square plus 1. Is it clear? And sin h pi. So you have to write here sin h pi and sin nx. It's already there. So therefore you get this value very easily. You can calculate this. You have calculated. So this is your answer, required answer, students. So please try this again and again. It will be perfect, right? Yes. If you have any doubt, please ask me, students. Yes. Thank you. Thank you, students.